So what are you guys?
We are the SWARTWOOD family.
So are you guys real SWARTWOOD MCAT students?
Hell yeah!
Okay. Then let's go to our first real topic, which is rates. Okay. So many problems can be done with just this formula. Distance is rate times time. Okay. And everybody buys that, right? This is like you're going 2 miles per hour, right? And then if you travel for 2 hours, it's like a bad flashback to GChem. These guys will kill each other, and you'll get a distance of 4 miles. So I kind of believe this formula. Right? It's also okay. But the idea is like, how can you apply it? So let's try 2 problems. Let's do problem number 1. Let's say you've got Anne and you've got Sue, or like make it Bob. Okay. And Anne drives at 20 miles per hour, and Bob drives at 40 miles per hour. Okay. And let's say Anne drives for 1 hour, and then Bob drives for 1 hour. Okay. So what you do is you have kind of a race. So first, Anne starts off, and she drives for 1 hour at 20 miles per hour, and then she hands the baton to Bob. Bob drives for 1 hour at 40 miles per hour, and then you stop the clock. And you ask, with their team combined over the total distance, what is the average velocity? What do you guys think? How would you compute the average rate? Yeah, I mean, when we're talking about the average rate, we're talking about what? Not over one part of the journey, but the whole journey, right? So you could do this. Distance is rate times time, and distance is rate times time, right? Okay, so we can figure this out. Like the guy's going like at 20, the time is 1, or she is, right? So the distance is what? 20. And then we go over here, the guy's going at what? 40, the time is 1, so the distance is what? 40. So how do you find the overall average rate? You got to do it one more time. It's all using the same thing. You want distance for the entire journey, total, is equal to the rate for the entire thing times the time, total. Does everybody agree?
Yes.
Okay. What's your total distance?
60.
You got it, 60. The 20 and the 40, right? It's got to be 60. Your rate, we don't know. What's the total time it took you?
2 hours.
2 hours. So the rate is 30. Okay. It seems like a mellow problem, but there's a reason why I'm doing this, because I want to contrast this with the other one you did in class before. So this guy is exactly what common sense says. If you're going 20 and you're going 40, then the average of 20 and 40 is 30. That's actually true. Okay. But now compare that. Everybody's okay with this problem, right? Compare that to this. Same thing. Do the same thing, but now I'm going to change the parameters slightly. So they're going to some restaurant. I mean, make them both Anne. Doesn't really matter. It could have been Bob. But Anne goes 20 miles per hour up there and then does her thing. Then she comes back. But when she makes a return trip, she goes at 40 miles per hour. Okay? What's her average speed? What do you guys think? 30?
Well,
It's not this guy. So it will never, ever be the average. But I wanted to show you an example where it really is the average, and let's compare the difference. So how could it be any different? I gave you the same rates. We're trying to find the average rate, right? But it's how I present the info. Last time what happened? You had 2 people, but they're traveling for the same amount of time. They're both traveling an hour. Here it's different because even though they're traveling the same distance, right? But they're not traveling the same amount of time. So that actually screws everything up. Okay, but let's compute it. So let's say Anne, what's she doing? She's going to do some distance. We don't know what it is, right? In fact, to make it concrete, you could do this for variables, but you want to just make up a distance? Make up one and make it pretty, so both 20 and 40 divide into it. What's an easy number they both go into? 20. 20 and 20 is good. Go even simpler, maybe just
80.
80 is good too, even simpler. 40? They will work on the 40, right? Yeah, let's do that. So let's say the distance is 40, right? And the rate Anne travels at is 20, right? So this is distance, is rate times time. So it took her how long? Yeah, it just took her 2 hours, right? So time is 2. Okay. That's for Anne going there. So this is Anne's time on the way there. So let's call that time 1. This is leg 1, leg 2. Okay. What about on the way back? So again, distance is rate times time. On the way back, the distance is still 40. Somebody agree? The rate is now what? 40. So the time here is 1. So this is time 2. Everybody agree with this? Okay. Now let's just do the same computation over again. The total distance is what? 40 there, 40 back, must be 80. The rate we don't know, but the time was what? 2 hours plus 1 hour, that must be 3 hours. Perfect. And as weird as that is, it's not 30. It's actually less than 30. Right. So rule of thumb, when you're given this sort of thing, when it's the same distance, but people are traveling at different rates, I mean, you don't have to memorize that, but the average will actually always be less. Okay. Well, the reason why this problem is different from the first one is how it's presented. The first one is the same amount of time. This one is the same distance there and back. Okay. Exaggerated example is if I walk to the board at an inch per day, and then I come back at the speed of light, if you just average speed of light an inch per day, it's still pretty damn fast. It should take like a couple seconds or something like that. But you can't make up for those days I've used up walking to the board. So the average, this rate, it's always going to be lower. Lower than just 40 plus 20 divided by 2.